The lesson topic for this video is finding ratios using a point. Okay, so a couple of things before we start our examples. Number one, I want you to remember that we have 6 trig ratios, and we're going to remind ourselves about those during this lesson. So we have sine, cosine, tangent, and then we have cosecant, secant, and cotangent. Keeping in mind that we know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then we have the 3 reciprocals. Cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and lastly we know that cotangent is adjacent over opposite. So just keep those things in mind. We will use them again in this lesson. Okay, so back to the topic at hand. It says, it says we're going to find ratios, these 6 ratios, using a point. Okay, so I'm going to put a point on this coordinate plane right here, this purple point. Okay, can I still draw an angle with that we know goes through that point, even if we don't know what theta is? Our original angle. Sure, we can definitely draw an angle. In standard position, we're going to put that original initial side on the x-axis, the positive x-axis, and if we know it goes through this point right here, then we know our second ray, or our terminal side, is going to go through that point. Okay, so that point was right about there. Okay, so we can still draw the angle. Now the question I have for you is, can we still find the reference angle? And the answer to that is yes, we can still find the reference angle. Again, same side as the terminal side, and then the closest portion of the x-axis will help us create theta prime. Okay, so now the next question is, can we still find the measure of that angle, theta prime? Well, the answer is we can if we know the coordinates of this point. And that is what we're going to work on in this lesson. So for the first example, these are the directions we're going to follow. The next example is a little different, so make sure you follow through to the third slide. Given a point on the terminal side of theta, so here is the point that we're given, it's on the terminal side of theta. Draw the angle in standard position and show that rotation with an arrow. Then we're going to label theta prime, the reference angle, of course, and then we're going to sketch a right triangle using theta prime, and then we're going to label all the sides with their lengths. Well, not really with their lengths. I'm going to talk more about that as we go. So the first thing we're going to do is we're going to put a point where 4, -13 exists on the coordinate plane. So we're going to just estimate this kind of. So if we know it moves right 4 and then down 13 for our point, if we kind of said this is about 4, if we just count off, 1, 2, 3, 4, okay, and then down 13, so -13 might be right around here. We know that our point is right here. Okay, now that point, as it says right here, the point is on the terminal side of theta. So we are going to draw our original angle theta in standard position. So here is our original ray, and then our initial ray, and then here is our terminal side going through that point for -13. Okay, so showing the rotation with that would be, this is that angle right here, all right, and that's our initial angle theta. Now we're going to label theta prime. Well, we know that theta prime is our reference angle. It's always created by the terminal side of the angle theta and the nearest portion of the x-axis. So that's right here. So we know that this is theta prime. Now the next step says to sketch a right triangle using theta prime. And what I mean by that is using theta prime as one of my angles in the right triangle. How we're going to do this is we are going to connect our point, this initial point, that point here that we started with, to the ray that's on our nearest x-axis. So we're just going to connect it straight up to our x-axis, and what's going to happen is we're going to create a perpendicular segment. And if we draw a perpendicular segment, it means we have a right angle right here, which means we have a right triangle, right? So we've created that right triangle using theta prime. Now we're going to label all of our sides with, and I said a minute ago, I said with their length, it's a little different, and I'm going to talk about that now. So we know we originally went out, I'm going to use a different color here, we went out to here, we went out 4 to the right. So we're going to say that that is 4. All right. Then we went down here to negative 13. Okay, we are going to call this right here negative 13. Now it's a direction that we're headed with that negative right there. I mean, we know from geometry that length is never negative. So yes, the length of this segment is not negative 13, but in reference to our position on the coordinate plane, we want to include the negative. So we went down 13, so we're going to say negative 13 right here. And then can we find this third side? Because we want to label all the sides. The thing is, we can find that third side by using what? Hopefully you said the Pythagorean Theorem. If we know two sides of a right triangle, we can find the third side by using a squared plus b squared equals c squared. So let's go ahead and put our two sides in as 4 and negative 13, and we're finding the hypotenuse, which is c. So we have 4 squared plus negative 13 squared equals c squared, which will be our hypotenuse. Well, 4 squared is 16 plus negative 13 squared. Negative times a negative is positive, so this is going to be 169 equals c squared. 16 plus 169 is 100, and let's do that here, 95 equals c squared. And remember, we need to square root both sides. We're going to square root here, and we're going to square root here. So c equals 13.964, and anytime we square root both sides, we're going to put plus or minus 13.964. Now, when we're talking about labeling our hypotenuse, we are talking about the length of the hypotenuse, which is not going to be negative. So this answer here can be 13.964. Again, this negative 13 helps us understand the position of our point, which is why we do show it as a negative. It's again kind of relating a position as well as a length. But our hypotenuse is the distance that this point is from 0, 0, which is going to be positive. Okay, so one last example, and the directions are very similar. We're going to use the same 3 first steps, but after we draw the right triangle and find the missing sides, we are actually going to go one more step and write the 6 trig ratios for theta prime. All right, so we start again with putting that point on the coordinate plane. So negative 5 maybe is right around here, negative 11 maybe right around down here. So this point is right here. We'll draw our original theta angle in standard position. Whoops, I'm going to try that again. Okay, like so. And then we are going to, excuse me, draw our reference angle. So this is our terminal side of the original angle and the nearest x-axis, portion of the x-axis. So now we're going to go ahead and say that this here is theta prime, and we're going to draw from that point straight up to form a right angle with the x-axis. Now we're going to label this portion of our right triangle right here negative 5, because we've gone from 0 to negative 5. Again, it's not the length of the segment because that would be positive, but the position of this point from the origin. And then this will be negative 11 right here. So we're going to use the Pythagorean Theorem. A squared, I'm just going to put it in the space here since I've got some space. A squared plus b squared equals c squared. We're going to put negative 5 in for one of our sides, squared, plus negative 11 for our other side, squared equals our c, or hypotenuse, squared. -5 squared. Remember, a number squared is always a positive, so make sure you never forget your parentheses if you're using your calculator for this. -5 squared is 25, plus -11 squared is 121, and that equals c squared. They add up to 146, and then we're going to square root both sides. We get c equals positive or negative 12.083. Kind of squish that in there, sorry. So our hypotenuse is 12.083. Again, our hypotenuse will always be positive. Okay, so we have done the steps. We've drawn our original angle. We've labeled theta prime our reference angle. We've sketched the right triangle using theta prime, and we've solved for all three sides. So now we are going to write our 6 trig ratios for theta prime. So sine of theta prime, cosine of theta prime, put those primes on there, tangent of theta prime. Then we've got cosecant of theta prime, secant of theta prime, and cotangent of theta prime. Sine is opposite over hypotenuse. So we are using this angle, theta prime, right here, as our angle, our reference angle. That's why we call it a reference angle. We're referencing this angle. So let's label our sides here. We haven't done that yet. So this is the opposite side over here, the 11, because it is opposite that reference angle. We know the hypotenuse is this side because it's across from the right angle, which leaves this to be the adjacent side. So sine is opposite over hypotenuse. Well, the opposite is -11. The hypotenuse is 12.083. Cosine is adjacent over hypotenuse. The adjacent is -5, and the hypotenuse again is 12.083. Tangent is opposite over adjacent, so -11 over -5. Cosecant is the reciprocal of sine. Now remember, we don't have to look back over here anymore. We can just look at our 3, as long as we're matching them up. We know sine and cosecant, cosine and secant, and then tangent and cotangent. So if we just take the reciprocals of each of those and write them here, we should be good. I'm going to make my pen a little thinner, see if I can fit those in there. So this will be 12.083 over -11. Secant will be 12.083 over -5, and cotangent will be -5 over -11.